Okay, so next we're going to look at another example and see what it looks like when A is not diagonalizable, so we can know what to look for when we're working these problems. So, same question, example, is A diagonalizable? All right, and let's do a bigger matrix. Let's do a 3 by 3. And down the columns, I have -4, 0, 0, 1, -4, 0, and 0, 0, 7. Okay, this also is a triangular matrix, so it's easy to find the eigenvalues. Remember, that's our first step. So eigenvalues are -4 and 7. All right, so A has eigenvalues, lambda equals -4 and 7. All right, so even though -4 is listed twice, it's just one number, right? It's -4. So you wouldn't list -4 twice because -4 is just one number. However, it means that the algebraic multiplicity is 2, since we got the -4 twice here. This eigenvalue has algebraic multiplicity 2. And since the 7 is only listed once, this eigenvalue has algebraic multiplicity 1, giving us a total of 3. So 3 by 3. All right, so now that we have the eigenvalues, we need the eigenvectors, right? So let's go ahead and set this up. We need our augmented matrix, so we need to do A plus 4i, 0 on the other side. All right, so this is going to give us down my column 0, 0, 0, 1, 0, 0, 0, 0, 11. All right, and we will put this into RREF to be able to solve it. All right, so I got 1, 0, 0 in the second column and 0, 1, 0. So what does that tell us? I'll actually walk through the whole general solution because this one is a little trickier to solve. All right, so do we have a pivot right here? We do not, so that tells us that our x1 is free. All right, our x2, here we got a 0, so x2 is 0, and then x3, which I could have reordered these, but we're here now. x3 is 0. You probably would want to switch our rows around. Well, actually, no, this would not be an RREF. Sorry, I'm having inner dialogue. We always want the zeros to be on the bottom in RREF. It's just a trickier one to solve. Okay, so we got anything 0, 0. So I'm just going to do x1 equals 1. Why not? You can choose whatever you want. So a basis for our eigenspace, A -4, is going to be 1, 0, 0. You could also choose 9, 0, 0 or -5, 0, 0. It's all fine. All right, next we need to use eigenvalue 7. So A minus 7i, 0 on the other side. All right, so down my columns, that's going to give me a negative 11, 0, 0, 1, negative 11, 0, and 0, 0, 0. All right, so then when I put my matrix into RREF, down my columns, I have 1, 0, 0, 0, 1, 0, 0, 0, 0. All right, and so the general solution, that one's a little easier. Oops, 0, 0, 0. Sorry, making mistakes here. X1 is 0, x2 is 0, x3 is free. So we can let x3 be anything we want. We're not going to choose 0 because we don't want our eigenvector to be 0, 0, 0. So I'm just going to choose 1. So a basis for our eigenspace A7 is 0, 0, 1. Okay, so our question is our matrix A diagonalizable? Well, based on the diagonalization theorem, we need to have n linearly independent eigenvectors. We have a 3 by 3 matrix, which means we need 3 linearly independent eigenvectors. We've only come up with 2. That is not enough. All right, every other eigenvector we get will be linearly dependent to either one of these. So we're only going to have 2 when we need 3. So our answer is no. A is not diagonalizable. Because when we put it together, our eigenbasis 1, 0, 0, 0, 0, 1, it's only in it doesn't form an eigenbasis in R3 because there's only 2 of them. All right, so what was the difference here? Why did this one not work? Well, we didn't have enough elements inside of our eigenbasis. We did not have enough eigenvectors. So this actually tells us something about the multiplicity, our geometric multiplicity. All right, so here's our note. If the dimension of our eigenspace A lambda, this is also known as the geometric multiplicity, so if our geometric multiplicity is less than our algebraic multiplicity, of lambda for an eigenvalue lambda of A, then A is not diagonalizable. All right, and I'll explain this as well. All right, so if the dimensions of our eigenspace is less than the algebraic multiplicity of our lambda, then A is not diagonalizable. So note, eigenvalue -4 had multiplicity 2. However, the dimension of our eigenspace for eigenvalue -4 has geometric multiplicity 1, since there's only one element. And since 1 is less than 2, that means that our matrix A is not diagonalizable.